Today we're looking at 4.8, solving nonlinear systems of equations. So a system of equations in two variables x, y consists of two or more equations. A solution of the system is an ordered pair x, y that satisfies each equation. Solutions correspond to points where the graphs of the equations of the system intersect. So here are three examples of some graphs. These are all include a parabola and a line. So it is possible for us to have no solution. That would be that the parabola and the line will never intersect. The line keeps going up forever this way, but the parabola goes in this way forever, and they never intersect. It is possible to have one solution where the vertex of the parabola just barely comes and touches the line. It is also possible to have two solutions if the line crosses through the parabola. Those are the three ways we can get solutions. So we're going to start by graphing. This is in vertex form, our parabola. We know it's a parabola because it has the x squared. When it's in vertex form, we're going to use transformations. This plus 4 is in parentheses. It does the opposite of what you think it's going to do. So plus 4 you would think is going to the right 4, but because it's a plus and it's inside parentheses, it does the opposite. So it's going to go left 4. The plus at the end has to do with the up down, but it does what you think it's going to do. So this is going to go in the positive direction too. So we're going to start at 0, 0. We're going to go left 4 and up 2. And that is where we're going to put our vertex. The axis of symmetry is going to go right on top of the vertex. Then we're going to use key points to finish off our parabola. We have our key points of 1, 1, 2, 4. There is not a number in front of the x. So that would be our a value. There's not an a value, so that means there's not a vertical stretch. So we're going to use these points to finish off our parabola. From the vertex, we're going to go over 1, up 1, and put a point. And we're also going to go over 2, up 4, and put a point there. These reflect across the axis of symmetry, and then we connect them into a smooth curve. The second one is in a line. You know it's in a line if it's in the form y equals mx plus b. B is where we begin. It is our y-intercept. So I'm going to start at 0, 0 and go up 6. And I'm going to put a point right here. My slope is whatever number is in front of the x, and we make it into a fraction. So I'm going to go up 1 over 1. That's the end of our graph, but we could also change this. We could also go the opposite way and just continue the graph here. Now there's 2 points where these two graphs intersect. This point here and this point here. We're going to write those points as ordered pairs. So we have, let's start with this point. We go left 1, 2, 3, 4, up 2. Left 4, up 2 is the point -4, positive 2. We also have the point here where we go left 3 and up 3. So we have a point at -3, positive 3. And those would be the solutions of these systems of equations. It's the points where the line and the parabola are crossing. Now looking at number 2, we have this first one. It is in standard form because there is an x squared and an x. So first we're going to write down our a, b, and c. A is -2, b is 4, and c is 3. We're going to use the equation x equals -b divided by 2a to get our axis of symmetry. B is 4, so we have -b, which is -4, divided by 2 times our a, which is -2. This gives us -4 divided by -4, so the axis of symmetry is going to be at x equals 1. I'm going to draw in the axis of symmetry. Now to find our vertex, we know that we're going to use that axis of symmetry. It's on that axis of symmetry, so our x has to be a 1. To find our y value, we're going to take that 1 and we're going to substitute it in for the equation to be able to get the y value. The y will equal whatever it is we put in for x. So we're going to have negative 2 times 1 squared plus 4 times 1 plus 3. 1 squared is 1. 1 times negative 2 is a negative 2. 4 times 1 is a 4 plus 3. 4 plus 3 is 7. 7 minus 2 is 5. So our y value there is going to be at 5. So I'm going to go over 1 up 1, 2, 3, 4, 5. And we're going to put in our vertex. Now to get the rest of the graph, we can use our y-intercept. Our y-intercept is always 0, c. Our c value is 3, so we're going to have another point at 0, 3. This graph reflects over the axis of symmetry. It's going to look something like this. On the second equation, we have the y equals mx plus b, so we know it's a line. The b is the y-intercept, or where we begin. We're going to begin, our y-intercept is at negative 1. I'm going to start at negative 1. My slope is my m. We need to have it, which is this 2, but we want to put it in a fraction so we can have our rise over run. So I'm going to put 2 over 1. So from this second point, I'm going to go up 2 over 1, up 2 over 1, and we're going to just plot those points there. Now, I do have one of my points where it's intersecting. This is over 2 up 3, so one of my points is going to be 2, 3. The problem is I haven't graphed enough of this parabola to get the rest of it. So what I'm going to do, if I want more points, I can always use the key points of 1, 1, 2, 4 to get the rest. Now, I've got my a value is a negative 2, so I'm going to take my x and my y. I'm going to take my y and times everything by a negative 2. That's my vertical stretch. So 4 times negative 2 is a negative 8. From my vertex, I'm going to go over 1, down 2, and I already have those points there. But to get more points, I'm going to go over 2 and down 8. And that's enough to give me my other intersection point. This is at negative 1, negative 3. So that gives me my 2 intersection points there. Now, instead of using a graph to find if there's 1 or 2 or no solutions, we are going to use algebra to solve this. Now, y is equaling x squared minus 6x plus 9. What we're going to do is we're going to take this x squared minus 6 plus 9 and substitute it into the y of the other equation. And what that does is it allows us to have all x's so we can solve this. Okay, so we're going to take this piece here and input it in for that y there. So I'm going to have x squared minus 6x plus 9 equals x minus 1. Now, if you have an x squared and an x, we want to set it equal to 0. So I want to get rid of all of this stuff here. I'm going to minus x from both sides of the equal sign. And then I'm going to add 1 to both sides of the equal sign. This equals 0. And then I'm going to look and see, I have an x squared and an x, so I want to look and see if it easily will factor. This would be an easy factoring, two things that add to negative 7 multiply to 10. I've got 2 times 5 is equals 7, but we want them to add to a negative 7. So if I take negative 2 times negative 5, that multiplies to equal a positive 10, but it also adds to be a negative 7. So those are my two numbers. I have a minus 2 and a minus 5. We're going to have x minus 2 equals 0 and x minus 5 equals 0. We add 2 to both sides of the equal sign, I get x equals positive 2. Add 5 to both sides of the equal sign, I get x equals positive 5. Now, we know that x equals 2 and x equals 5, but remember, we're not looking for just what the x is. We want something like this where we have ordered pairs. So we're going to have a 2 for my x and a 5 for my x. Now we go ahead and get what the y is. Now we could get the y by plugging it into the first equation or the second equation, but one is much easier than the other. It's much easier to substitute in for the second equation than the first one. So I'm not going to use that first one. I'm going to use the second one, but both of them would work. So if I take my 2 and substitute it in for x, 2 minus 1 is a 1. So that is what I would get for my y value. And if I substitute the 5 in for x, 5 minus 1 is a 4. So I get a 4 for my y value. So these would be the two ordered pairs where the solution intersects. Okay, let's look at number 4. Again, we have y equals x squared minus 3x minus 3. We take this piece and substitute it in for the other y value. This is going to give us x squared minus 3x minus 3 equals negative 5x. Notice this y, instead of putting a y, we put this value here because y is equal to that. We want to set it equal to 0. We're going to add 5x to both sides of the equal sign. We want to see, does this easily factor? We want to look and see if that's the case. It would be an easy one. 2 numbers that add to 2 and multiply to negative 3. We've got 1 and 3. If I put a negative 1 times a positive 3, that equals a negative 3, and a negative 1 plus 3 equals 2. So those are our 2 numbers. We're going to use the zero product property. We're going to set each of these equal to 0. X minus 1 equals 0 and x plus 3 equals 0. Add 1 to both sides. Minus 3 from both sides. We have our 2 points. We only have the x values, x equals 1 and x equals negative 3. Now to get the y values, we're going to take these numbers and add and input them into, we're going to take our x values, input them into either equation. Now the first one is a lot harder to plug into than the second one. So all we're going to do is we're going to take negative 5 and times it by that 1. We're going to just put that 1 in there, and that gives us a negative 5 for the y value. For the second one, we're going to take our negative 3, substitute it in for x. Negative 5 times negative 3 is a positive 15. And that would give us our 2 answers, our 2 ordered pairs where the graph intersects. Okay, y is equal to 3x squared plus 4x minus 1. And we have y minus 2x equals 4. So since y equals this piece here, we're going to take it and substitute it in for y. So we have all x's. So we're going to just substitute that in. So we're going to have 3x squared plus 4x minus 1 in for our y value. Then we're going to write everything else the same. Minus 2x equals 4. We have an x squared and an x. So what we want to do is we want to set it equal to 0. And we also want to combine like terms here, like that 4x and the minus 2x can go together. So we're going to have 3x squared. 4x minus 2x is just a plus 2x. And then I'm going to minus 4 from both sides of the equal sign. I get minus 5 equals 0. Now looking here, I want to see, it has an x squared and an x, so I want to see, does this easily factor? So let's just look and see, this has a number in the front, so this would be a lightning bolt problem. So we're going to take 3 times negative 5 is negative 15. We want 2 numbers that multiply to negative 15 and add to a positive 2. So what about 3 and 5? If I have 3 3 times 5 is 15, but those are two numbers apart. So I need it to add to a positive 2. What if I put in negative 3, positive 5? Negative 3 times positive 5 is negative 15, and negative 3 plus 5 is a positive 2. So those are my two numbers that I'm going to rewrite the 2x to equal. So if I take negative 3x plus 5x and add those together, they give me 2x. So I haven't changed the problem, I've just split apart those like terms. I put in my lightning bolt. I have a 3 and an x in both of these pieces, so I'm going to divide a 3x out of each of those. If I divide this by 3x, I still have an x left. I'm going to have my parenthesis x minus 3x divided by 3x gives me that negative 1 there. So I'm going to put a negative 1. Whatever sign you have here, you bring it down. Look at this next two pieces. They both have a 5, so we're going to factor the 5 out of both of those. And I have x minus 1. My first term is going to be 3x plus 5. My second term is going to be x minus 1. You're going to have both of these here. You're going to set it equal to 0. So now I have two things multiplying to equal 0, so I use my zero product property, and I'm going to set each piece equal to 0. 3x plus 5 equals 0, and x minus 1 equals 0. On this first one, I'm going to minus 5 from both sides of the equal sign. I get 3x equals negative 5, divide by 3, and my x equals negative 5 thirds. On the second one, all I have to do is add 1 to both sides, and x equals 1. So we're going to have 2 points. We're going to have one of the x's is 1, and one of the x's is negative 5 thirds. Now we have two options. We can take the 1 and substitute it in both of these places for x, or we can take this 1 and substitute it in for this x here. Now since this is a smaller one, I'm going to probably put it in there. I have y minus 2x equals 4. Now let's go ahead and get y alone so we can solve for it. I'm going to add 2x to both sides of the equal sign, and my y equals 2x plus 4. So I'm going to take my 1 and substitute it in. I have 2 times 1 plus 4. 2 plus 4 is 6. For my other piece, I'm going to take negative 5 thirds and substitute it in for the y value. Negative 5 thirds and substitute it in for the x. So I'm going to have 2 times negative 5 thirds plus 4. I have negative 10 thirds plus 4. We're going to get a common denominator by timesing the top and bottom by 3 over 3. And I'm going to have 12 thirds and minus 10 thirds. Add those together and you get 2 thirds. So we're going to have 2 thirds here. Now this is one of the main reasons algebra works so much better than graphing, is because we can get exact answers here. Now if I graph this, it would be really hard to tell exactly where they were intersecting if it's not on a point. So algebra is a good way, especially if you get something weird like negative 5 thirds and 2 thirds. Number 6, we're going to take our x minus 2, y equals x minus 2, so we're going to substitute it in for the y of the other equation. So we're going to say x minus 2 equals x squared plus 8x minus 2. We have an x squared and an x, so we want to set it equal to 0. Now what I don't want to do is I don't want to take this stuff to this side. I want a positive x squared so that I can try to factor. So I'm going to minus x this way and add 2 to both sides. I get 0 equals x squared plus 7x. The plus 2 and minus 2 cancel. Now I have an x squared and an x, but I don't have that third term. So this is a place where people tend to forget how to factor here. But this is where we have a greatest common factor. They both have an x, so we're just going to pull the x off, pull it out, divide both pieces by x. X squared divided by x is just an x is left, plus 7x divided by x is a 7. This equals 0, so we're going to set each piece equal to 0. So we're going to say x equals 0 and x plus 7 equals 0. We're going to minus 7 from both sides of the equal sign, and x equals negative 7, x equals 0. We've got our 2 points. On one of the points, x is equaling 0, and on the other one, our x is in negative 7. Now you want to look and see which one looks easier to plug into. This first one looks a lot easier to plug in than the second one. So we're going to be using that first piece right here to substitute into y equals x minus 2. So first one I'm going to take is that 0 and plug it in for x. 0 minus 2 equals a negative 2. So the y is going to be equaling a negative 2 when the x equals 0. On the second one, we're going to take that negative 7, plug it in for x. Negative 7 minus 2 is negative 9. So when the x is negative 7, the y is going to equal a negative 9. And that will give us our 2 points. We have 2x squared minus 8x plus 9. We're going to substitute it in for y here. 2x squared minus 8x plus 9 in for this y equals, and then we just write this right side, x squared minus 4x plus 6. Now we have 2x squareds. We've got to figure out which way we want to take all of our x squareds, because we need it to be positive. So if I minus 2x squared from both of these, x squared minus 2x squared would give me a negative x squared. That I do not want that. So what I'm going to do is I'm going to take all of this stuff on the right and pull it to the left. I'm going to minus x squared, add 4x, and minus 6 from both sides. Minus x squared plus 4x minus 6. Okay, everything on the right side is going to cancel. I'm going to get a 0 there. 2x squared minus an x squared is x squared. Negative 4x plus 4x, or negative 8x plus 4x is a negative 4x, and 9 minus 6 is a 3. This looks like it would be easy to factor. Two things that add to negative 4 multiplies to 3. We've got 1, and 1 times 3 is the only things that multiply to equal 3, but we're wanting these two numbers to add to a negative 4. So if I make them both negative, a negative 3 times a negative 1 is a positive 3, and a negative 3 plus a negative 1 is a negative 4. So those are going to be my two answers there. X minus 1 and x minus 3. This equals 0. Product property says if two things are multiplying to equal 0, then either the first one has to equal 0 or the second one has to equal 0. So we're going to add 1 to both sides of the equal sign. X equals 1. Add 3 to both sides of the equal sign, and x equals 3. So we have 2 points. We're going to have one of the x's is a 1, the other one is a 3. And we want to look and see which one is going to be easier of these two equations, which one's going to be easier to solve for. Now, they're really close, but I'm going to pick that second one. And the reason why is because this one has a 2 here and this one doesn't. And I don't want to have a number times 3 numbers together here. So I'm going to pick this second one. It looks just a tiny bit easier. It's not much easier though. X squared, so y equals x squared minus 4x plus 6. I'm going to take my x and substitute it in. So I'm going to have a 1 squared minus 4 times 1 plus 6. 1 squared is 1 minus 4 plus 6. This equals a 1 plus 2, which equals 3. So when the x is 1, the y is equaling 3. Now we're going to do our second number by plugging a 3 in for x. 3 squared minus 4 times 3 plus 6. We have 9 minus 12 plus 6. 9 plus 6 is 15 minus 12 is going to equal a 3. So we have the points 1, 3, and 3, 3 as our answers. A city has 2 public skate parks. Since opening day, attendance at Park A has increased steadily, while attendance at Park B rose and then fell. So one is going up in a straight line, and one is an upside down parabola. It went up, but then it fell down. On what days was the attendance the same at both parks? So we're looking for how many days. X is the number of days. So we only want to know on that part how many days it was after it opened. And then after that, we're going to plug it in to find out how many people were at the park that day. So we're going to take 28x plus 6 and substitute it in for the y. Now, if you look at this, I have a negative x squared. If I'm going to factor this, that negative has to be out. It has to be a positive number. So we're going to take everything on the right and pull it to the left side. So we're going to take and add x squared minus 39x and minus 66 from both sides of the equal sign. We're going to set that equal to 0. We have x squared minus 11x minus 60 equals 0. We're going to factor this. We're looking for two things that add to negative 11 and multiply to 60. So let's see if we can find that. We've got 1, 62, and 30, 3 and 20, 4 and 15. If I have a negative 15 and a positive 4, those two numbers would work. So we're going to have x plus 4, x minus 15 equals 0. We're going to set each piece equal to 0. Zero product property says if there's two things multiplied to equal 0, either the first one has to equal 0 or the second one has to equal 0. So we minus 4 from both sides. X equals negative 4. Add 15 to both sides, and x equals 15. So here's the problem. If I have a negative 4 days since the park opened, that doesn't make a lot of sense. So we're going to cross out this negative 4, and it's just going to be 15 days after opening. And this is when attendance was the same. Now we want to know what the attendance was. All we have to do is take that 15 and substitute it into either piece. Now, I don't want to put it in the second one because it's a little more complicated. We're going to take 28 and multiply it by 15 and then add 6. And this is going to give us 426 people attended both parks on that day.